Hi, welcome, and thank you for stopping by my poster. My name is August Lee, and I am a fifth-year graduate student at Dr. Raj Nar's lab. Part of the lab's focus has been on discovering the endogenous sialoglycan ligands that bind to Siglec-8, and this poster shows our latest finding. Okay, first, some background information. Siglec-8 is expressed prominently on eosinophils and mast cells, and it contains inhibitory domains that downregulate allergic inflammation, making Siglec-8 an ideal drug target for treating allergic inflammatory disorders such as severe asthma and eosinophilic esophagitis. Here are the four synthetic glycan structures of Siglec-8 ligands. Especially important is this 6-position sulfate on the galactose on these structures that's absolutely required for Siglec-8 binding. We don't know so much about the endogenous Siglec-8 ligands though. On here I have a keratin sulfate structure, and as you can see, if keratin sulfate is alpha-2,3 sialylated and sulfated the right way, it may look very much the same with some of these synthetic Siglec-8 ligands.
To look for the endogenous Siglec-8 ligands in the human esophagus, I first did immunohistochemistry staining. And here I'm just zooming in to show a submucosal glandular structure of the human esophagus. This is an H&E staining. Here you see a glandular duct. And then in panel B and C, I am doing a Siglec-8 FC overlay with the sections treated with PBS in B and sialidase in C. So the red things in panel B are the Siglec-8 ligands, concentrated mostly in the mucous cells of the submucosal glands of the human esophagus, as well as in the ducts. And all of this stuff is sialidase sensitive. So next, I can use biochemical methods and extract the crude Siglec-8 ligands using 6-molar guanidinium and then ethanol precipitate to concentrate and further extract.
And the next step of extraction and purification will be subjecting the samples to a size exclusion chromatography. And then finally, I can perform a Siglec-8 FC affinity capture to purify the esophageal Siglec-8 ligand. I was able to elute out a concentrated S8 ligand with 1 molar salt. And this is a material that I processed and sent for mass spectrometry analysis. So MUC5B protein has been identified with mass spectrometry to be the protein carrier of our Siglec-8 esophageal ligands. I am just showing here a cartoon figure of MUC5B with these domains, and up here I've marked wherever the unique peptides that appeared in the mass spec that fits into the general MUC5B structure. And lastly, just to confirm that MUC5B is indeed the protein carrier of the Siglec-8 ligand. So here with immunofluorescence, I'm showing that the Siglec-8 FC signal and the anti-MUC5B antibody signal co-localizes on the esophageal sections, again in the submucosal glands. And on Western blots, you can also see Siglec-8 signal co-migrates with MUC5B. So to conclude, endogenous Siglec-8 ligands in the human esophagus are sialylated keratin sulfate chains on MUC5B. They're synthesized in submucosal glands and secreted into ducts that connects with the esophageal lumen, which is where in diseases where eosinophils reside. So this is not the first time that we have isolated Siglec-8 ligands from human tissues. So it appears that in different human tissues, we have a mechanism that selectively put the Siglec-8 ligands onto different proteins. And the regulation of this is still just a mystery. So yeah, a lot more to do on the project. Studying the functions of these endogenous Siglec-8 ligands would be the natural next step, and also to get some patient samples and analyze the amount of ligands versus MUC5B